All right. It's better if you open your CSV file in Excel here, so you can see things better, but it's fine if you don't. Okay, so the first thing is, as always, you import the libraries, you read your data set, and you do df.head so you can see it. Now, the problem here is, no, wait. Mm, Okay, when you do df.head, the problem is that you won't be able to see all of these columns, okay, because there are 35 columns here and you will only be able to see 20 of them, okay, because there is a maximum limit on the number of columns you can see. So what you do is you set the max columns to none, okay, and when you do that, in your case, because I've already run these cells, so in your case, you will be able to see all your columns now when you run this cell. Okay. And you print the shape, you do df.info, and then you find that most of these are again object type. Okay, and then what we need to do is convert them to int or float. The maximum number of columns we can convert. Okay. Now see, playback used has about 18, no, exactly 1800 null values, which might create a problem. Same with bird scene. Background has very few values. Maximum of them are null values. So we can consider dropping this column, but not before looking like seeing what it looks like. Okay, not before that. This also has only 15,000 values, non-null values. So what we do is, because there are 35 columns here, we print the columns that have the null values. Okay, so we see that there are 5 columns. Bitrate also has this. See, okay. It has very less null values, but it does have them. So we can consider adding mean or something to that. So we can remove these. Okay, so you print the column names and you see if there is some trailing space or something that is not right. But here I find that all of them are okay. And they do tell you what is happening where, except in some columns, which we'll see later, what the problem is there. Okay, when you do describe, since only a few have int object type, so you only get those. We will run this cell one more time at the end. Mute yourself.
सेक्स मचा दो यार मेरा भाई खुद नहीं मिल रही कि बहन तो हंसता ही नहीं है
एक सेकंड
Okay, that was something. Anyways. Okay, so the first column you see is the rating column. We'll go through all the columns one by one. And this time we are going to go through all these columns. Okay, not one of them we are going to leave. Okay, so you print the unique values in rating. And you see that most of these are fine. If you see this space, it just means it's 0.0. Okay, that is not printed, but it is just 0.0. So 0.0 to 5.0, we have all the values and they all seem perfect. So rating is not one column that we don't need to do anything for. Then we go to playback used column. This meet is going to get quite repetitive because we are going to do the same thing for every column. Bear with me because this is what you are going to do as well. Okay, and one more thing, I'm not going to share this file with you, this notebook, because I need you to do the work. This video will be available on YouTube, you can watch it, but I won't be sharing this because all you'll do then is copy paste. Okay, and that is not something. Is it of any significance? Okay. That is one thing I was also thinking of, if it was of some significance or not. But since we are not exclusively given what does this column represent. So we have to assume things on our own. So maybe we can assume that it's rating based on how exotic that bird is or how good the audio is. Like say a better rating if an audio has a better rating, maybe it has very less background noise and it's very clear. So we don't exactly know what it specifies, but we need to keep it just in case it is important. Okay. And one more thing. Okay, I need you guys to answer this. So we created a neural network, right? We did EDA, we did FE, we also created a neural network. But the point was, when we created the neural network, we did not use a CSV file in order to create that. Okay, all we did was use TensorFlow or Keras or PyTorch or some library, and we created a model. We did not use the CSV file. So why is it that we need to clean all of this? Because in order to create a neural network, we don't need all of these. What we do there is we directly give the audio to that model. So why do we need to manage this CSV file? What is the point? If anyone wants me to unmute them, you can raise your hand or you can just type it in the chat box. Mhm. Maybe we'll add these features along with MFCC. Yes, that is a good answer. That is a very good answer, actually. See, generally, when we try to find patterns on our own, what neural network does is it finds a pattern on its own. Okay, it does not really need us to give it the data. Yes, that is also one reason. Very good. Okay, so what happens is when you are working with traditional machine learning models, okay, I showed you two, right? I showed you linear regression and I showed you SVM, support vector machine. So what happens is when we have those kinds of models, we need to give them some parameters. Okay, some good parameters. The more parameters we give them, the better they perform. We can give them all of these 35 columns. Okay, and it will find some patterns based on all of these because they cannot exactly find patterns from the audio itself. It's hard for them to do that. Neural networks are much better in that case. So this project is supposed to be about neural networks, but you can also do the classification based on traditional machine learning models. Okay, so if you are even if after this project is over, you can try on your own to create a traditional machine learning model that uses these columns, any value from these columns that feels important to you, and you can try to see which audio is refers to which bird. Okay, so that basically traditional learning models is basically why we need to clean the CSV files. Okay, and find patterns on our own so we know which column is useful and which is not. And like Samat said, we can also add these to our neural network model. That is also one thing we can do. Okay, no, we already ran this set. So we were at playback use. Rating was perfectly fine. Yeah, one thing you can do with rating is you can convert it with label encoders. Like you can do it. It is not necessary because rating is pretty clear what is happening. But if you want to, you can do that. Now we go for playback used. And we see that there are some null values there. So we find, okay, Okay, so there's mostly no. There are very few audios where playback is used. What is playback? It is um, it is basically using a voice to call the bird. Okay, like if you play a noise, a particular bird will answer to that voice, and then you will be able to record the audio of that bird. Okay, that is what playback used means basically. Okay, now since maximum values here are no, we can just fill them with a no. Okay, so we do that. And now we only have no and yes values. Okay. Now here you can use label encoder, which is very, very simple. It's either 0 or 1. 0 for no, 1 for yes. Okay, so that's done. We have a new column called playback used encoded. And now if you want, you can drop this. Playback used column can be dropped because it is of no significance now. We have it encoded. Okay, very good question, Samarth. Should we drop rows that have yes playback since it won't represent true bird voice? Now, yes, obviously we can do that. But the one good thing about neural networks is we can remove background noise. Okay, since you can assume that a call was used to call the other bird, you can assume that the audio we have would mainly have the voice of the bird we were supposed to record. Okay, like we can call from our end and then we can start recording. Okay, so that is generally how it happens. You won't generally find in the audios the voices of two birds. Okay, that is very rare and it is not very often that it happens. So yes, while we can do that, I suggest that we don't, because when we create our neural network model, we can remove any background noise we have. But it's a little complicated process, so I'm not sure if I will show you how guys how to do it, because our model is already going to be a little complex. Okay, you guys know the basics of everything, but our model is going to be complex. So that is something you guys will have to work on. And again, I will explain each and every line to you guys. So you can, even after the project is done, you can come back anytime, watch the videos, try to understand what is happening and modify it as you go. Okay, as you learn new things, you can modify it. Okay, and then we give space. Okay, now we have one more column here when we describe it. Okay, we don't need to print. Right. Okay, the next column we have is eBird code. Okay. This is why I have printed df.head at many places, because I will otherwise need to scroll a lot. And this way you can also see the changes you are making. Okay, playback used encoded is here, but playback used is not here anymore. Okay, so you see there are a lot of different birds here. eBird code is maybe it's a code for that bird because the species is here. And the secondary labels also. We'll look at what those are later. Okay, you can consider this like a nickname for that bird. Okay. And if you print n unique will print the number of unique values you have. Okay, all you need to do before unique is add an n. And then you'll find ki, okay, there are 264 unique values. Okay, there is not much you can do here. Again, if when we are adding these values to our neural network model, we will need to encode these. Okay, we'll need to encode these and then we'll add these there, because this is what the model will be predicting. Okay, and whatever it is predicting, it cannot be a string value or an object. So we will, when we do the model, we'll convert this into numerical values using label encoders. Okay, so this is not something we can do much here. Then we see channels. There's one mono and two stereo. Okay. Now you already know what Librosa does is it will convert this stereo into mono as well. Okay. Okay. So you have mono and stereo. There are no other values. So this is okay. Now what you need to do is you need to convert it into integer value, right? So what you do is you take this, just this part. Okay, so you do str and you strip it and you take the first digit, which is either 1 or 2. Okay, and you convert it into integer data type. And then you have 1 or 2. Okay, that is what you have here. Okay. Um, right. So I've only kept these values in order to create a graph. Okay, so if you need to find key, okay, how many values are mono, how many were stereo. Okay, this particular column is not going to matter to our neural network model because like I said, Librosa will convert all of them to mono. It does not matter if they were stereo or mono or whatever else, it will be converted to mono. Now why is this giving an error here? Okay. Okay, so we have the next column is date and we have 3522 different values here. Now, one thing we can do is we can split it. Okay, split the year, the month and the date. Okay, we can split that based on this dash, the hyphen. So we split that based on the hyphen. The first part of it, this is the year. So we create a column for year and we convert it into int data type. The second one is the months. So we do that. And the third one is the day of the month. So we do that. Now this will help us if we want to create a graph where we want to see, okay, which year was it when most of the recordings were retrieved. Okay. Or which month was it that was the best for recording different bird songs. Okay. So when we need to analyze all of that, that is when we will require this. If we use date, then that would not be happening because it has 3522 different values. Okay. And now we can drop this date column because we have all the values we need. Okay. Yes, Samar, it does not have a direct relation with our neural network model. But the thing is that we don't only need to think about our model, we also need to think about the implications of it. Because if we are trying to recognize the bird, we are trying to basically recognize ki, okay, this was an endangered bird, but I recorded that particular bird this number of times. I need to find which are the months where it is most active or when it sings. Okay, those are some things that we need to think of. It's not related to our model, but it is related to the ecological impact. Okay, these are some things we need to analyze. We don't only think of the model. We need to think of far-reaching aspects of whatever data we have, whatever information we can extract from it, however little or however insignificant it might seem, we need to see. Okay. Yes, that is correct, Viral. And how will we know it only comes out in summer? Because these are not something that this is not something that people always know. If it is a very exotic bird, people try all year to find it. Okay. And if we find ki, okay, it only has the audio between August to November, so we can know ki, okay, that is the time when it comes out in that particular country. Okay. The place matters as well. We also have, see, we have the exact location and we also have the country. See, we also have the country. Okay. So there are a lot of things that matter when we are doing this. All right, so channels is fine, date is done. Then we have the pitch. Oh, why did I do this? Nothing. Okay, so we are done with these particular columns. Okay, I think it's pretty okay. The pitch is either not specified, it's both increasing, level, or decreasing. Okay, I think it's pretty okay. You can use label encoder here as well. It's also great. So we find the value counts. Value counts give us the count of how many values are there in each category. Okay, so maximum of them are not specified. So what we can do is we can also think of dropping this column. Okay, since it is not exactly giving us a lot of information, but try not to always drop the columns, because there might be places where if um, if the pitch is level, maybe there are only three kinds of birds that have a pitch in level column. Okay, that have a level pitch. If it's decreasing, maybe particularly only two types of bird have a decreasing pitch. Okay, so there are things you need to analyze with your data, and then you need to decide, okay, is this column worth dropping, or should I just keep it for the sake it might be useful in the future. So I have not dropped it. Okay, now, okay, then we have the duration of the audio, I believe. So you find the unique values here, and there are a lot of them. As far as I can see, there is not a problem with it, except this, when the duration is written to be 0. So maybe it is only 0.2 seconds, because if the duration is 0, then we don't exactly have an audio, right? I don't see any null values here, so I think this is okay. And I believe this should not be seconds. It should be some other metric, other unit, but this should not be second. Okay, and then we have the file name. So this is obviously going to be different for all audios. Not much we can do here, but we need this because we will need to iterate through all the files. So this is one column we need. And then we have speed. Okay, it's pretty much the same as pitch. Now, one thing we can do is we can find if pitch and speed are somehow related. Okay, um, if the pitch is not specified, then the speed is not specified either. If the pitch is both, then this is both as well. If pitch is level, then speed is level as well. If pitch is increasing, then this is accelerating. Okay, we can try to see if that is the case or not. If it is the case, then we can drop one of those columns. And if not, we have to keep both of them. Okay. And then we have species. There are 264 of them because there are 264 birds as well that we will need to classify. And then we have the scientific name. Again, 264, not much we can do here. We don't exactly need these columns, but you can consider dropping them when you do the EDA. Okay. And then we have number of nodes. Now, here we see that it's either not specified or it is in the range of 1 to 3. Okay, these are ranges. Now, before in one of the meets, I told you guys how to deal with ranges. You can find this as the minimum one, this as the maximum one. I have not done it here, but I have done it later in the notebook, which you'll see. It was for another column, but it's pretty much the same thing. So you'll know how to do that. Okay, so this you can do with this one. And then we have a column named title. Speed is done, species is done, number of notes is done, and then we have title. You see there are a lot of different values here which do not seem like they're important for our purposes. See, again, there are different unique values for all of them because we had 21,375 rows in total, and every row has a unique value. So it can either be used as an identifier for each and every row, or you can just drop it. Since we have a lot of values for the same bird, like we can use the scientific name because each bird is going to have its own scientific name. But if you want to identify rows, title can be one of the one of the columns you can do it with. Okay. And then we have this column called secondary labels. Okay. Now um, what I believed is happening here is maybe these are some, say, nicknames, like you call some bird with a particular name. So it is a secondary label for that bird. Okay. So it's not its scientific name. It's not exactly its nickname, but it is like maybe for in different parts of the world, it is known with different names. And that is what secondary labels signify. Again, a lot of values, nothing we can do here. You can consider dropping this column as well. And then we have the bird seen. Okay, if the bird was spotted or not. Now, sometimes the bird was seen, sometimes it was not, and sometimes it is not specified if it was seen. So we find the value count. Okay, so maximum time the bird was seen. So what you can consider is you can maybe consider replacing this with yes. Okay, but it is basically completely dependent on your own judgment. And then we have, no, scientific name is done already, but okay. Um, okay, and the next thing we have is location. Now, in this location part, what we have is it's stated very precisely where the bird was located. It's not the state, it's not the country, it's a lot of things. Okay, so this I have only kept this value because we will be using this to create a map later. Okay, we will create a map and we will specify exactly at every point where the bird is located. And then we have the latitude and longitude. This can also be used to create the map. Again, a lot of different values. Now, the problem with this latitude is that its type is object. Okay. See, the type is object here, except the values are floating integers. So you convert latitude, and there is also a column called longitude. Okay, so you convert both of them to float. But the problem here is there are some places where it is written that it is not specified. Okay, the latitude and longitude are not specified. So what we do is we drop those. Okay, where it is not specified, we drop those particular rows. Okay, those are done, and then we convert it. Okay. Now, one thing I did not show here, I don't know why, is that you need to see, okay, how many of these are here. Okay, how many of these values are not specified. If it's a very large number, you cannot drop those rows, right? But if it is a small number, you can consider doing that. And this is growing as we go. Okay, I'll print it once again. Okay, and then we have the sampling rate. The next thing is sampling rate. So we find the unique values here. Again, you see the hertz part is completely unnecessary. We do not need that. So what we do is we split it based on the space and we take only the first value. Okay. And then we convert it to int data type because that is important. If you don't convert it to int, you won't be able to use these values as an integer. It will be an object. And if you try to find, okay, which birds have the sampling rate of 48,000, it won't give you results. because this is a string. It is not a number unless you convert it into an integer. Okay, so you do that. Okay, I think I already did that or something. Wait up. Okay, I think I already did that. So this is split. Okay, the next thing we have is type. Okay, now this is a little complicated because you'll see why. If you print the number of unique values, it's 1255. Okay, and if you print the unique values here, actually, there are, see, if in one column it's called song, vocal, and mechanical sounds. Okay, the values are like this. So what we do here is we split them based on the comma. Okay, and we create a separate row for each of them. Okay, this is a completely different data frame that we are creating because we cannot do it in the same data frame. We cannot create more rows there. So what we do here is we convert them into different rows. Okay, so if this was the case, so what we'll have is one row that says call, another that says song, another that says vocal, another that says mechanical sound. And what it will do is it will count. Okay, and then there's this thing called calls. So calls and call is same, so we replace calls with call. And then we find, okay, how many unique values are here? So we see there are a lot of them, right? There are a lot of ways these are specified, a lot of them. And there are very unique ways of classifying them as well. See, it says juvenile calls, something says white song question mark. So it is one column that you can safely ignore. And that is it for this meeting. We will continue from here. Okay. Okay, I'll print df.head once again. Okay, so we went till type and we saw that there are a lot of different values here and we cannot do a lot of with them. So next is elevation. So you print the unique values here and you see that there is this meter thing and then we have unknown and see we have question mark, we have a range, again one more question mark. And there was also one value where, okay, see this, minus nothing. Okay, no number here. And then there's 3.1, 3.3. The meter is 2 times. There's a lot of problems here. Okay. Okay, so we see that there is no clear mod here. So we cannot exactly replace the unknown values with a particular number. That will not exactly work. But the first thing we do is we split it based on the space. Okay, so we do that and we try to convert it into an integer. But it won't work because we have question mark here. So what we do is we replace this question mark and all of these things, the unknown and the place where there was nothing, to 5 times 9. Okay, this is a value you won't see anywhere. So it is just a number. If you can write any number, just try to find something that won't be here in these. Okay, so we do that. And we replace, okay, no, wait. I'll run this once again. Again, it will create a problem because there's the decimal places. And you see there is no value where decimal places are needed. Okay, there are nothing that screams, okay, a decimal is needed. So I'm assuming that these were placed by mistake. Okay, you can also assume that you can also round them off to say 3. Okay, But I am assuming here that maybe they were placed by an error because there is no other this kind of value anywhere. So I replace the dot with nothing. And then I try to run it. Again, we find an error because this is there. Okay. So what we'll do is we'll also replace that. Okay. And now if we try to run it, still a problem because there's a range there. Okay. Display. No, wait. Hmm. Okay, so we are taking the first value out of that. No, wait. The meter is there. Okay. Okay. The first thing we'll need to do here it's not working directly. So what we'll need to do is find the values where this dash exists. Okay. And you iterate it through your entire data frame and you find the values where dash exists and then you find the minimum value and then you run this. Okay. Now, even after you do that, there will be another problem with this comma. Okay. There are values which use a comma. For example, mm, do you see any values like those here? Um, okay, I cannot find them, but there are values here that use a comma and that cannot be converted to int data type. Okay, say it's 1000 comma 285. Okay, so then you'll need to replace again that comma with nothing. And then after you're done with all of this and then you run this, then this particular column will be dealt with. But there's a problem that we have this here. Okay, we replace some values with 5 times 9. Okay, now what we need to do is what I have done here is I have found the mean. Okay, and then replace that with the mean value. Okay, so I have taken the rows where the value is not 5 times 9. I have done the sum, added the count. Okay, counting the rows where the value is not 5 times 9, and then I've calculated the mean and then printed it. Okay, now this is not working because our column is not dealt with properly. I don't know why it should be running, but okay, I'll see it later. Um, and just to confirm if this mean is the same, if this mean is different from the one we are supposed to have because these values are not here. So this mean will be a lower value. And if you try to find the mean of the entire column, that will be a different value. And then you replace this value with the mean you calculated. Okay. That is what I have done. It is not necessary for you to do the same thing. Okay. And then there is a column called description. Okay. It's fairly long thing. It also has some image links and stuff, and we do not need this at all. Okay. So we drop that column. Then comes bit rate. Okay. Bit rate of MP3. Okay. We find the unique values here, a lot of them. And if we try to find the value counts, we see that the maximum values are here in this 1,28,000 bits per rate. Okay, that is the most common. So what you can do if you have null values or if you need to replace, if you have to replace, you can replace them with this value because it's the most common one. Okay, and it is very common by a large factor. Okay, if this was 3000 and this was 2800, 2500, then we would not have been able to do that. Like it was the case here. Okay, this is 2200, 1500. We cannot do that here because it's not obvious that something is like much more in quantity than the other. Here we can do that. Okay, now the problem here was when I printed this entire thing, I found that at one place there was a 0. Okay. Okay. I've already run this before, so I think that is why it is not showing here. But when you do that, what will happen is you will have one value here. Okay. No, wait. Okay. No, this was because, okay. What is the data type here? It says int, right? But the problem is that it's not actually int. This is an object data type. Okay. This data type you see is for the values. Okay, this is not for the values you have in the column. This is for value count. Okay, and the count obviously will have the data type of integer, but the values inside this column are object data type. And here you are trying to find a number. Okay, like I said, if you need to find a string, you need to have it in quotes. Okay, otherwise it will not recognize it. And if you do that, then you run and then you'll find if there is a value for 0, then you'll find it here. 3. Okay. Okay. The problem here was that one of the columns had the value 3 here. Okay. This was what I was trying to run. One value was 3. And the problem with that column was when you will do this, you will realize that that exists. So this all of these columns were empty. Okay, all of them were empty. So what I did was I dropped that particular row. Okay, where the value was 3. One reason because 3 is not possible since we have values in lakhs. Okay, so that is not possible to have 3 bit rate of MP3. Okay, so that was not possible. So that value was incorrect. Plus, all of these were not a number. Okay, all of these were empty null values. So I dropped that particular row. Okay, so you find if there are any null values here. And you see there are quite a lot of, okay, see, bitrate null. Okay, all of these have null values here. So what you can do is you can either fill them with this particular value or you can find the mean. Any one you see is fine. Okay. Any of them works. Oh, and you need to replace this first. Okay. Split this based on the space and then this part will be gone. All you'll be left with is an integer and you can easily do dot mod and you'll get the mod value and then you can replace the null values with this particular value. Okay. And then we try to see what is the file type, which is our next column. Okay, it's pretty clear. Everything is okay here. Then we find the volume. Okay, again, this can be compared to pitch and speed both and try to see if the pitch is increasing, then the volume is increasing. If the pitch is level, then the volume is level. If that is the case, again, this column can be dropped completely. Okay. And then we have background. You can see that there will be a lot of different values here, but there are also a lot of null values here. We saw in the beginning that it has very less values that are of any use. Okay, most of them are null values. We do a value count and okay, there is one value that is 124 times. Okay, so these are used in the background. These can actually represent it might be possible that it represents some values that were some audio that was used to call the birds. Okay, it might be possible that that is the case. So you need to check if that is true. And how will you do that? You compare it with the column. Where was it? Playback used. Okay, you compare it with that. If the values coincide, then okay, that is that. And if they don't, then we don't exactly have a lot of work here. Now we see there are only about 8,000 values in this column we saw in the beginning. Now, since there are over 5,500 values and they are not even very common, so this particular column can be dropped. And then we have something called XC underscore ID, which again, we have no idea what it is about. So we see the number of unique values and we see that almost all of them have a unique value. So this can also be an identifier if you want one. But the values in our, the total rows we have are, I think, 21,375. So some of them do not have a value. Okay, or at least they don't have a unique value. So again, this can be dropped. It is not of much use to us. We find the URL, it's pretty much the same. And what, uh, okay, the URL is not exactly giving us any particular information we need or we can use. So again, that can be dropped as well. And then we have the country. Okay, now this is important. And we see that things are pretty okay here. Every value is good. There are no trailing spaces. The values are good here. So not much we can do unless you want to do label encoding, that you can do. It's totally fine. And even if you don't, it's okay. Now see, when you try to plot the graph for country, you cannot plot it for every country. Okay, I mean, you can do it, but it won't exactly look very pretty or very nice. Like it won't give you some information. So what you can do is you can try to find top 10 countries where the birds are spotted, or the top or the bottom 10 countries, okay, where birds cannot be spotted. Okay, or a very few number of birds were spotted basically. Okay, so top 10 and bottom 10, that is what you can do. You cannot plot all of them. Oh, and one more thing that we are going to do is we are going to create a map of these. Okay, we are going to create a world map, and it will have different colors based on the number of birds found per country. Okay, so that would be a nice thing to do if you want to plot all of them. Next we have, okay, see, there are two columns here. One is author and one is recordist. Okay, these are the two values we have. And now you can see that the value for author coincide with the value of recordist. Okay, but again, you cannot assume that they are the same. So what you'll need to do, okay, first we find the unique number of authors, it's 941. Unique number of recordists, also 941, but it's still not enough. So what we do is we print the values where the author is not equal to recordist. And there are no values here. Okay, this is an empty row, which means that everywhere the value in author is equal to the value in recordist. So what we do is we drop one of them. I dropped author because since we are recording the bird songs, recordist makes more sense to me. You can also drop recordists. It's totally fine. And then we have something called a primary label. Okay. This seems a little like something related to the scientific name of that particular bird. Okay, that is what it looks like. Okay, so we print the unique values there. And there are a lot of them. Okay, not much that can be done here. You can drop this column. There are too many values here, just like the secondary label. And then we have the values in lengths. Now, this is what I was talking to you about, replacing them based on the dash. Okay, finding this minimum value, and then there's a maximum value. These two cells will run later. First, we do this. First, we find the digit. The first digit we find, which is either 0, 6, 10, or 3. Okay, that is the first digit we find, and that will be our minimum digit because it is greater than 10. So 10 is the minimum. Okay. And we print df dot head. Okay, see. Okay, see, since it is not specified, we have not a number. Here we have 0 to 3 always. So the minimum values is always 0 here. Okay. And okay, we try to print the unique values here. Now from this, we should have either not specified, 0, 6, 10, or 3. And that is exactly what we have. Okay. So minimum value is working as far as we are concerned. Next, we do the same thing for maximum value. Okay, it tries to find the digit from the end. Okay, so the first digit we find from the end, it's either 6 or here, since 10 is already gone, so we don't have anything here. And then here we have 10, 3, and again, it's not a number, not specified. Okay, so we print the unique values in max. And see, you have 3, you have 10, and you have 6. Here you don't have anything because it is not specified. So it comes under not a number. Okay, along with not specified. So it comes there. And now you can drop this column. The length column, you can drop it. But I would choose not to drop it because it does give us a range. So if we want to plot a graph, so we can know, okay, how many values are there in the range. You can do the same thing with these two columns as well. But this is a more direct approach. Okay. That is why I have not dropped that particular column. Now we have the time column. Again, you print the unique values here, and there are a lot of them. Okay. If you print n unique, see 14.5 thousand, almost 1.4K. That is the number of unique values we have in time. So those are a lot. So what we do is we drop it because the time is not exactly of concern to us because unless you think of a way to round it off. Okay, like we agreed that maybe it's useful for us to find the months or the year when the particular bird was spotted. So what you can do is also you can find the time. Okay, maybe a particular bird only comes out at night. Maybe it only comes between 2 to 4 p.m. Maybe it only comes in the morning. Those are some things you can think of doing. Okay. And there are things that you will need to do that are different from my notebook because this is your project. Okay. All I am doing, all I'm supposed to do is guide you through it. The basically the model building and everything, you are supposed to do that. I'm not going to just give you the codes so you can just copy paste. You're going to have to think. You're going to have to implement a lot of things that I have missed. Okay. Or something that you don't agree with me. If I drop the column and you think no, that column is important. Or if I kept a column, but you think no, that column is not important at all. If I dealt with null values a different way, but you want them to deal with them in a different way. You need to think about all of those things. You need to understand what you think is right, what your intuition tells you, and you do that with your data. Okay. And this is going to be a very lengthy notebook because you have 35 columns here. Okay. 35 columns is not a small amount of columns. Okay. All right, and then we print the license, which is basically our last column. Okay, playback use this. These are the columns we created, but other than that, this is a last column. And it's good that we only have 4 values here, so we can use label encoding here. Okay, and it's done. And now we can drop the license column. Now this is basically what our final data is going to look like, except that one column that had some trouble. Except that one, this is basically what our data is going to look like. And then you do describe and you find more values here. Okay. Now, for the plotting part, I have not done a lot of plots here, but I want you guys to think and to decide which kind of plot you can make. I have already given you a list of the plots you can make. Okay, it's in the resources, right? So you must know the kinds of plots you can make. You need to find the best plot for something. Okay. Um, all right. So I began with the rating part. Okay, I only have very few columns to, very few graphs to show you, but I did the rating one and I created a count plot. Okay, so this is how it goes from top to bottom. Okay, maximum of them have 5 rating and very less of them have low rating. And then the next column was playback used. Okay, no, wait, this should not be there. Mm. Playback used encoded is the one we have. Okay. See, I created a different graph. It could have been vertical as well, but I created a different graph because this was already done. Okay, you don't want to have similar kinds of graph continuously because that would not make your data analysis appealing. Okay, and if it is not appealing, no one would want to go through it and see it because it would all seem like the same thing. No one is going to like always read, okay, like this is count versus rating. If there is another same graph, they will read this is something versus something. So not everyone is going to do that, and it is a very tedious task. So what you do is you try different things. Okay, so they can look at it with a fresh perspective. Okay, and then I plotted a graph to see whether, oh, okay, so this is the graph I created. So I could see the colors are not very good here. What I wanted to see was if the playback used has any effect on the rating. Okay, so as you can see, it does not really matter a lot because most of the time you use that or either you don't. But it's not exactly a very fair assumption because we saw that most of the times playback is not used. Okay, so the maximum values will be here only. So even if you have a good rating or you have a bad rating, the no part will always be taller. Okay, so it does not exactly give us some useful information. Now, one thing I wanted you guys to know is this, since these colors are not exactly very appealing, this was fine. And this was, I used a particular palette here. Okay, you can use different palettes. There are a lot of them that are already there. But what you can also do is you can create your own palette. Okay, you can choose the colors, you can create your palette and you can make it look prettier. And that is what I did here. In the number of notes, okay, see, number of notes has some ranges, right? I did not split it, it has some ranges. So what I did was I created a chart for it and see, these are the colors I specified. Okay, different colors, RGB values, RGBA. A is the this opacity. Okay, if it is 0, it will be completely transparent, so you won't see any color. And if it is 1, it will be completely visible. Okay, so you can play around with it, see what kind of colors fit your data best. Okay, and I had to divide these by 255 because when you're using these values, they only take values between 0 and 1. Okay, and RGB values are from 0 to 255. So I had to divide them all by 255. And I did not select these colors uh, looking through Google. What I have is this website. It's coolers.co and it has a lot of beautiful palettes. Okay, there are a lot of palettes you can use here. Okay, so you can just click on any one of them. Um, okay, you can open that palette. And what you can do is, see, You can convert these to RGB values if you need them. You can also use hexadecimal code. Okay, that also works fine with the model we have. Okay, that will also work. So that you can use, and whichever colors you want to use. If you only have three, then you can use either pink, yellow, and blue maybe. Okay, so you can use any three of them. Okay, so I'll run this one. Okay, see. Now the problem here is that these two are overlapping with each other, which is not a very good thing. So to avoid them, maybe you can increase the size. See, now they are not overlapping, and the graph is pretty clear, and someone would want to understand, okay, what is happening here, right? These are the kinds of graph that I need you guys to make. Okay, at first, for this particular thing, for the number of nodes distribution, what I created was a pie chart. Okay, this is a donut chart basically. So I created a pie chart, but it was not as appealing. It did not exactly look as good as it was supposed to. So I changed it. Okay, I could have shown you that as well, but I deleted that cell. But it was not looking as good. So what I did was I did this. And one more thing, when I created this graph, what I had was these values, that these values you see in the legend, these were written here. Okay, right along the colors. Okay, they were written here and they were not looking very good. So what I did was I removed them from here, only kept the percentage because that is important. And I created a legend separately. So you can see, okay, it makes it much more clearer and much more nicer to look at. Okay, and it is extremely easy to understand. All right, so that is what I did. Now, okay, now what I need you guys to do is, you don't have a lot of time. So do not spend too much time here, because we need to spend more time on our model building. And since it is going to be a lot of work, it's complicated. It's not as easy. This is not a very beginner level project. So even if I'm going to explain everything to you, you need to understand all of that for your final quiz. Okay, you will have one last final quiz based on the model. Okay, whatever we do in the model, that is what your quiz will be about. And it will be conducted on 10th. Okay, 10th for the guys who did not take 1 week off, and 14th for the guys who did take a week off. Okay, that is how it's going to work. And I'll send you guys the details for the report later. Uh, okay, and one more thing that I did not do in my analysis was I did not write. Okay, if I'm say dropping this, so I need to write something here. Okay, like I need to write it before this. So I need to write something here. Okay, this is why I am going to delete or drop my column. This is the next thing I'm going to do. This so there are some things like you don't need to write okay, now time column is done, so our next column is license, so I'm going to find the unique values of license. You don't need to do that. But if you do something called say if you do the label encoding, you need to give me a good reason. It only had 4 values and they were very lengthy. So what I did was I encoded them, made it simpler. And because they are already encoded, I don't need this anymore, so I'm dropping this. Okay, there are some things I need you guys to write. Any column you drop, any column you don't drop, or something like that. The logic, basically the logic behind whatever you're doing, that I need you guys to write. Okay. Um, all right, that is it for the meeting. Let me just take your attendance first. Okay, your attendance is done, and it will only be marked present if you're there in both of those meetings. So that's it for now.